Hi students, in this video we are going to discuss implementation of deletion operation in a binary search tree. So implementation of deletion operation in a binary search tree. Already problem we have solved in the previous video. If you have not seen, see that video. Then it is easy to understand this program. For deletion operation, so we will write the insertion as usual. That insertion program also we discussed in the previous video. So insertion function here we have written, and the three traversals. One is in order, next one is a pre-order, and the next one is a post-order. All these three traversals already we have written. Now this insertion we have called and the traversals. This is as usual similar to insertion. The same insertion program here I have copied. Now in this just I am adding the deletion function. So how to perform deletion operation. Now let us start the deletion function in a binary search tree. So deletion function in a binary search tree. So now, struct node star. So the function name here I am considering is del. So then struct two parameters this function is taking. Struct star node or struct node star. So root, for example, I am taking root, and the element, which element you want to delete, that we are passing as a parameter. So now, so deletion operation. Now first check what about root node. If root equal to null, then tree is empty. So simply what we will do is simply return null, you can write, or return root node. That root consisting of already null pointer now. So that root node null pointer will be returned. Suppose if that root node is not equal to null, then how to delete? First we have to find out where is that element, whether it is in the left subtree or in the right subtree, that we have to do. So how can we do that one? Just to compare. If element is less than roots data, then simply on left subtree we had to compare. So root of left equal to del of root of left comma ele. Now if element is less than that node, then we will search on the left subtree. If the element is greater, if it is not less, then it may be greater. So else if element is greater than roots data, then we have to search in the right subtree. Right equal to del of on right subtree. So that's why root of right comma ele. Else, that means it is not present in the left subtree, it is not present in the right subtree. So recursively we are searching, and it is not less, it is not greater, means what does it mean? It is equal. What does it mean? It is equal. Then how to delete? So now the three cases here we will get. So else, so one child case and no children case, we will write only one block. So no children and single child case. So now, so one child case means left may present right equal to null, or left may not present right equal to null. Like that, two cases you will get. If, that's why here we are checking if root of left equal to null. That means left side there is no child. That means right may present. So That's why here that right we will store in the temporary variable. So temp equal to root of right, and that root node we have to delete. That means that is equal now. The element to be searched is a root node. That's why we have to delete. Okay. And return temp. Now else if here left is null, right may present. Another case is right equal to null, left child may present. So if root of right equal to null, then the same thing. Now left null, we stored right child in the temp. Now here right equal to null, we will store left in the temporary variable. Temp equal to root of left. Then free that. In both the cases we have to delete that node. So free. What is the free function here? Deallocating the memory or deleting. Okay. Now again return temp. That's it. So this is one child case or no children case. Okay. So now two children case. What is two children case here? So two children case means, so we have to replace that node with minimum element from the right subtree. So minimum element, we will find out that minimum element in separate function, that is like find min. Okay. Some here I will take like a min node equal to find minimum. So we have to find a minimum element on right subtree. So right subtree is nothing but root of right. So now we got a minimum element from the right subtree. After getting the minimum element, what shall we do? We have to replace that element with this minimum element. So how to write that one? So root of data equal to this minimum node data. So min node data, and then we have to delete this minimum node. So how to delete this minimum node? Just call recursively the same function, del function. So now how to delete it? So root of that we are deleting on right side. So root of right equal to the same function, del of on right hand side, root of right, comma, what is the data now? So the data is min node data. Which one we have to delete? That minimum node we have to delete. Okay. So now here this else if is closed here, this if is closed, now this else is closed here. Okay. Now return root node. Now that else is closed, and finally close that function. I'm saving the program. See all the closes here. So this if is closed, this if is closed, this else is closed here, and this function is closed here. Okay. So now what shall we do? Now we have to write this find min function. So find minimum. This also returns a node. So struct bst underscore node star. What is the function name we considered? Find min. Then struct bst underscore node star some ptr. Okay. So now everything is bst underscore node. Here also we have to write a bst underscore node. See the node structure what we have considered here. BST underscore node. So here also BST underscore node, BST underscore node. Okay, and in this function we used this temporary variable. Now declare that temp also, like struct BST underscore node star temp. Okay, now how to find out? Now take one additional node. So that additional variable I'm declaring struct BST underscore node current equal to some that PTR. Now minimum element is present in the left subtree, left side, that minimum element is present. That's why we will move on to left subtree. So current while of current node left not equal to null. Move on to left subtree. Current equal to current of left, and finally return that current node. That will be the minimum element in the right subtree. Okay, so now we will call that deletion function. Now here already del node is declared. Some del node equal to function name is del some ptr comma 5 I want to delete. Okay, after deleting we want to display the in-order traversal, so that we will write here. So here I will write in the new line, after deletion the binary search tree in order of PTR. That's it. As usual the elements will be displayed after deleting 5. Now let us verify. Let us execute. Find min. Yeah, find min function declaration we have not given. Na? Declare function prototype. I am giving this function prototype. Here you can use. See, in this deletion function we are using this find min function. That's why here we have to declare. Otherwise, write this function before this deletion function, then it won't ask. Okay. So now again compile and execute. Save it. Compile and execute. Now it is showing some error like if root equal to null. Root already we have declared. Why it is giving error? Let us check. So return no root node. Yeah, we will verify it once. Save that program. Now here it is showing an error. See, here we missed a semicolon. Put the semicolon. Save. Execute it. See, don't feel like fear. So just rectify that error. You will get it. Don't worry. So compile and execute. Now enter element to delete. Enter element to delete. For example, I want to delete 15. Now let us see what happened. After deletion 15 is deleted. So the elements are like this. Okay. Now see what happened. See the main function. In main function, so it should not ask. Now which element we want to delete? 5 we want to delete. It has to delete it. Okay. So now compile. No errors. Now execute. Now see. After deletion the binary search tree elements are. See, we have deleted 5 now. So then remaining elements are displayed in the ascending order. So that's it. Deletion program in a binary search tree. So deletion operation in a binary search tree. Hope you understand, students. If you have any doubt, please comment me in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.